Today we are going to learn about module 2, that mathematical induction and permutations we are going to see. So what is mathematical induction? First we have to know what is well ordering principle. It is nothing but every non-empty subset of positive integers contains a smallest element. That is, what is z plus? It is set of all positive integers. It starts from 1, 2, 3, okay, etc. It is an infinite set. So if you take subset from this, it is 4, 5, 6. If we can take, yes, it is a subset of z plus. It contains the smallest element, right? This is well ordering principle. So what is mathematical induction? So an open statement will be given, mathematical statement will be given. So first we have to check for the initial value, that is step 1. If it is true for initial value, then you can assume that it is true for some k. Okay, and then you have to prove it for immediately next value, that is k plus 1. If you have assumed for k, then you have to prove for the next value k plus 1. This is mathematical induction. So here we are having one problem. Use mathematical induction to prove that 5 divides n power 5 minus n whenever n is a non-negative integer. Okay, what is given here? It is, we have to prove 5 divides n power 5 minus n. Okay, so n power 5 minus n is divided by 5. We have to prove this. Okay, so here we have to go with the basic step first. What is basic step? You have to take the value of n as 1. If you take n as 1, it is 1 power 5 minus 1, it is equal to 0. Yes, 0 is divided by 5. So next you have to assume that the result is true for k. For n is equal to k, the result is true. What is the result? The result is true. What is the result? Here k power 5 minus k is divided by 5. We are assuming that it is true. Okay, and we are going to prove for the next value, that is for n is equal to k plus 1. We are going to prove. So instead of k, we are having here n, we are having here k plus 1. So k plus 1 the whole power 5 minus k plus 1. What is the formula? It is a plus b the whole power 5 formula. A power 5 plus 5 times of a power 4, b power 1 is 1 power 1. It is, that is 1 power 1 is 1. Okay, so plus 10 times of k cube, b squared is 1 squared, plus 10 times of k squared, a squared, b cube we will get, b cube is 1 cube. So you will get 10k squared plus 5ab power 4. So 1 power 4 is 1. So you will get 5k plus b power 5 is 1. So this is expansion of k plus 1 the whole power 5 minus what we will get, it is k plus 1. Okay, so here you can club these two terms, k power 5 and minus k. Why? So we know that k power 5 minus k is divided by 5. 5 divides this value. So you can club these two things. Okay, so here we will get k power 5 minus k power 5 minus k, plus we are having the remaining terms as it is, 5k power 4 plus 10k cube plus 10k squared plus 5k plus 1, and here we are having, we have taken minus k already, minus 1. So minus 1 and plus 1 will become 0. In the remaining terms you can observe 5 is common, right? So it is equal to k power 5 minus k plus 5 times of k power 4 plus 2 times of k cube plus 2 times of k squared plus 5 times of k. Okay, so this is a multiple of 5. Already we know this term is divided by 5. So obviously this addition is also divided by 5. So what is this addition? It is nothing but k plus 1 the whole power 5 minus k plus 1, right? K plus 1 the whole power 5 minus k plus 1 is divided by 5. We have proved. Okay. So next example is, here we have one example. For each n belongs to positive integer, we have to prove 1 squared plus 3 squared plus 5 squared plus etc plus 2n minus 1 the whole squared is equal to 1 by 3 times of n into 2n minus 1 into 2n plus 1. Okay, so first we will go with basic step. What is basic step? You have to take n as 1. If you take n as 1, 1 squared plus 3 squared plus 5 squared plus etc plus 2n minus 1 the whole square must be equal to what we have to prove? It must be equal to 1 by 3 times of n into 2n minus 1 into 2n plus 1 we have to prove. Okay, so instead of n we are going to replace here by 1. So if you replace n by 1, what you will get? It is 1 into 2 is 2. 2 minus 1 is 1. So 1 squared is 1. So 1 by 3 times of here n, it will become 1. 2 minus 1 is 1. So 1 into 1 into, here we will get 1. 2 into 1 is 2 plus 1 is 3. So 3 and 3 will go off. So you will get 1 is equal to 1. So for basic step we have proved that the result is true. Next we have to assume that the result is true for n is equal to k. Assume. Okay. Assume that result is true for n is equal to k. If n is equal to k, then we have to prove the result is true. So how we can prove it is, if you replace 1 n by k, it is 1 squared plus 3 squared plus etc. It is k squared. No, it is 2n minus 1, right? So instead of n we are going to put 2k minus 1 the whole squared. It is equal to 1 by 3 times of k into 2k minus 1 into 2k plus 1. So we assumed it is true. We are getting for k. Okay. So next we have to prove it for k plus 1. So when n is equal to k plus 1, what we will get? It is 1 squared plus 3 squared plus etc plus the previous term is 2k minus 1 the whole squared. The next term is, instead of n we have to replace by k plus 1, right? So you will replace 2 times of k plus 1 minus 1. 2n minus 1 the whole squared is the last term. So we have to prove for this. So it is equal to, what is it? It is equal to, it is nothing but 1 squared plus 3 squared plus etc plus 2k minus 1 the whole squared plus, if you multiply 2 inside, it is 2k plus 2 minus 1 we will get. It is 2k plus 1 the whole squared. But already we know this value. What is it equal to? It is equal to 1 by 3 times of this value is equal to 1 by 3 times of k into 2k minus 1 into 2k plus 1, right? So we can replace here. It is 1 by 3 times of it is equal to k into 2k minus 1 into 2k plus 1 plus, already we are having here 2k plus 1 the whole squared. So we have 2k plus 1 common in these two terms, right? So you can take it out. So 2k plus 1, if you take off, it will become 1 by 3 times of k into 2k minus 1 plus 2k plus 1. 2k plus 1 will be inside. So what we will get? It is same as 2k plus 1 times of, if you multiply k and 2k minus 1 inside, it is 2k squared minus k, and 3 is here, we have 3 in denominator, so you can multiply here, multiply and divide by 3. Okay, take LCM, it is 6k plus 3 divided by 3. So you can add these two terms since we are having the common denominator. So it is 2k plus 1 times of 2k squared minus k plus 6k plus 3 divided by 3. What is minus 6, plus 6k and minus k will become plus 5k. So it is same as 2 times of k plus 1 into 2k squared plus 5k plus 3 divided by 3. So how we can write 5k? 5k can be written as, it is 2k plus 1 into 2k squared plus 2k plus 3k. It is 5k plus 3 divided by 3. So here we are having 2k common and here we are having 3 common. So you can take it out. So it will be equal to, it is equal to 2k plus 1 times of 2k into k plus 1 plus 3. If you take common, it is 3 times of k plus 1 by 3. So k plus 1 and k plus 1 is common. So you can take it out. It is same as 2k plus 1 times of 2k plus 3. We have taken this k plus 1 common. So it is 2k plus 3 divided by 3. So how we can write this? It is 1 by 3 times of k plus 1 into 2k plus 3 into 2k plus 1 into 2k plus 3. In the order we can write, it is in increasing order, right? See here, k plus 1, 2k plus 3. So n into what we have to prove? 1 by 3 times of n into 2n minus 1 into 2n plus 1. Instead of n, we have replaced here k plus 1. So if you replace here k plus 1, 2k plus 2 minus 1 will become 2k plus 1, and here it is 2k plus 3. Okay, so this is the final answer. So we have proved for k plus 1. So the statement is it is proved for every integer. Okay, it is proved for every integer n. So next problem is here, prove that every positive integer n greater than or equal to 24 can be written as sum of 5s or and or 7s. You can write it as sum of 5s or and, both. You can include 5 also, 7 also, or it may be only in terms of 5 or in terms of 7 only. So it is n is greater than or equal to 24. What is the statement? Open mathematical statement. Yes, n is n greater than or equal to 24 can be written as sum of 5s or 7s. Okay, so Sn is given as n greater than or equal to 24 can be written as sum of 5s and or 7s. Okay, so how we can prove this? By mathematical induction. So first basic step is for n is equal to 1. Okay, if we will start always with 1, but see here, what is the initial value? It is n greater than or equal to 24. We have to start from 24. So here we have to go with 24 first. So n is equal to 24. So 24 should be written as sum of 7s and 5s. So how we can write? It is 2 7 plus 2 5. So 5 plus 5 10, 7 plus 7 14. So you can write like this. Yes. So we have written 24 as a sum of 7s and 5s. Okay. So for a basic step, the result is true. So next we have to assume for k. So for n is equal to k, what is the result? It is k can be written as sum of 7s. Okay, we don't know what is k, or 5s, right? So this is the actual form. So we have assumed that for n is equal to k, the result is true. So next we have to prove for k plus 1. So already we know k can be written as sum of 7s or 5s and or 5s, okay, plus what we are having, it is 1. So this 1 should be removed and it should be written in terms of 7 or 5. So take 2 7 from here. There will be more 7s. Okay, at least 2 7s will be here. Okay, so since the starting number is 24, so k must be strictly greater than 24. Even in 24 we are having 2 7s. So k must be having at least 2 7s, that is more than 2 7s. So we can take 2 7s. So club these 2 7s with 1. So what is this addition? 7 plus 7 plus 1 will become 15. So now you will get extra 3 5s and 2 7s will be removed. If we are having total numbers r here, r 7s we are having and s 5 we are having. Okay, so here we have removed 2 7s. Okay, so what is the total number of 7s we will be having here? It is 7 plus etc. will be r minus 2. We have removed 2 7s and we are going to add 3 more 5s. 5 3s are 15, right? So we are going to add 3 more 5s in this here. Already we are having s 5s, and if we add 3 more 5s, it is s plus 3 in number. Okay, so we have the value of k plus 1 as summation of 7 and 5s. So in here we have removed this 1 by clubbing this 1 with 2 7s. Okay, so here you have to write like this: by clubbing 2 7s with this 1, so we will get 3 5s. So we can add 3 5s by removing 2 7s with, by adding this 1 with 2 7s. Okay, so this is how we can write k plus 1 as summation of 7s or 5s and or 5s. Okay, so we have proved the result for k plus 1, hence the result is proved for every n. Okay, so what is rule of sum? So there are m tasks. So first task can be performed in n1 ways, second task can be performed in n2 ways, and third task can be performed in n3 ways. Similarly, mth task can be performed in nm ways. Then the number of ways to do one of the tasks, that is one task, one of these tasks to be performed, that is this or this, this or this. So any one should be performed, that is you have to add all these values, that is n1 plus n2 plus n3 plus etc plus nm. Okay, what is rule of product? All these tasks to be done, then you have to multiply all this n1 into n2 into etc up to nm. Okay, so this is rule of product. So what is permutation? It is by using rule of sum and product only we are writing the formula for permutation and combination. Okay, so what is permutation? Permutation is nothing but arrangement. Okay, so whenever there is a word arrangement, arrange these letters. Okay, so you have to use permutation formula. So here what is permutation formula? Arrangement of r objects out of n objects, that is p of n comma r. What is the formula? It is n into n minus 1 into n minus 2 etc n minus or minus 1. So these many ways. See, first we are having r objects, right? 1 2 etc up to r. The first object can be arranged in n ways. So second object can be arranged in n minus 1 ways. So etc. You will get rth object can be arranged in n minus or minus 1 ways. So if you multiply here, we are having n into n minus 1 into etc. up to n minus r minus 1 base, right? So if you multiply minus inside, it is n into n minus 1 etc. n minus r plus 1 we will get. Okay, so next what we are going to do is, it is multiplication of n minus r plus 1 minus 1. This is the next term, right? The terms will be reducing. Okay, so plus multiplication of n minus plus 1 and minus 1 will go off, so you will get n minus r. So n minus r minus 1 etc. What will be the last term? It is 1 divided by, we are going to do this, n minus r into n minus r minus 1 etc. 1. We are going to multiply and divide by these terms, so that what we will get, it is 1 into 2 into, here we are having 1 into 2 into etc. up to n. This is nothing but n factorial divided by, here what we are having, it is 1 into 2 into etc. up to n minus r. So what is the formula of permutation? N factorial divided by n minus or the whole factorial. It is the formula for permutation. So we have to use in the problems. Clear? So what is the first problem given here? It is, we have to find the number of permutation of the word. Okay, this word is given MASSASAUGA. Okay, so how many of these 4 A's are together, we have to find. There are 3 questions here. First we have to find number of permutations of this word, and in how many of these 4 A's are together, and how many of them begin with yes, we have to find. Okay, so word is this. Okay, what is m occurs how many times? 1 time. A is occurring for 4 times, 4 A's are there, and S is 3 times, and U occurs for 1 time, G is also 1. Okay, so here we have to find how many permutations are there. Okay, how many permutations, how many arrangements, how many ways we can arrange all these words. Okay, so what is permutation? It is P of, formula for permutation is P of n comma r, it is equal to n factorial divided by n minus or the whole factorial if none of the letters are repeated. So but here A is repeated for 4 times, S is repeated for 3 times. So you will get how many letters are there totally? So it is 4 plus 3 plus 1 plus 1. So you will get 10 letters, right? So what is the permutation? It is 10 factorial divided by how many times A is repeated? It is repeated for 4 times, and S is repeated for 3 times, right? So you will get 4 factorial into 3 factorial into M is repeated for 1 time, U is also repeated for 1 time, G is also repeated for 1 time. So 1 factorial into 1 factorial into 1 factorial. It is the number of ways of arranging these 10 letters in their places. Okay, so here 10 factorial divided by 4 factorial into 3 factorial, it is equal to, you will get it as 25,200. Okay, so this is the answer for first question. What is the second question? How many of these all 4 A's are together? So in these number of permutation, how many of these permutation, all the A's will be together. Okay, so that means we are having 4A, right? So you have to consider this 4A as a single letter. So how many letters will be remaining? So totally there are 10 letters, and we are considering, and we are removing these 4A's. So there will be 6 letters, and we are considering these all 4 as only 1 letter. So how many letters are there totally? It is 7 letters. So it is, how many ways are there? 7 factorial divided by How many letters are repeated? We are considering 4a as single letter and s will be 3, remaining all are 1. So 3 factorial into a is also you have to consider as 1. So it is 1 factorial, m is 1 factorial, a and u is also occurring only one time. So g is also occurring one time. So it is equal to 7 factorial divided by 3 factorial. The value you will get it as 840. Okay, so this is the answer for second subdivision. So what they have asked in the third question, how many of them begin with yes? Okay, so here how many s are there? It is 3 s are there, right? So what are the remaining words? M, a, u, g, right? So here how many positions are there? 1 2 3 4 5 6 7. Yes, so we are having, okay, 4 a's are there, right? So one more a will be there. So we are having how many positions? 1 2 3 4 5 6 7 8. Okay, already one was taken, so first letter always begin with yes. Okay, so how many ways we can arrange all these letters in these 8 position? That is, s can occupy first position, it will occupy one s will occupy first position. Okay, so remaining letters, how many letters are there? 1 2 3 4 5 6 and 7 we are having, and 2 more letters also there. So you will add 7 plus 2, that is equal to 9. So there are 9 factorial ways. 9 factorial ways. And how many letters are repeated? S is repeated for 2 times. Already we are having 3 s, but we are considering here only 2 s. So it is 2 factorial into a is 4 factorial, m is 1 factorial, u is 1 factorial, and g is also 1 factorial. So 9 factorial divided by 2 factorial into 4 factorial into 1 factorial into 1 factorial. The value is 7560 you will get. Okay, so this is how you have to find the answer for these problems. So next problem is how many positive integers n we can form using the digits 3, 4, 4, 5, 5, 6, 7. If we want n to exceed 50 lakhs, it is above 50 lakhs it should be. Okay, so what are the digits we are having? 3, it is occurring for 1 times, 4 is occurring for 2 times, 5 is occurring for 2 times, and 6 and 7 for 1 time, right? So here we want the number should exceed 50 lakhs. So here the starting number should not be 3. If you take the starting number as 3, it will not exceed 50 lakhs. So and it should not be 4 also. It can be 5, 6 or 7. So what is the first value? It can be, first number can be 5. So if you take first number as 5, it is fixed. So how many digits are left? It is 7 numbers total, 7 digits are there, right? So we have fixed the first digit is 5. Okay, so remaining 6 values will be occupied, right? So how many ways we can give these values? See here, we have given first value was 5, so remaining 6 places are there. So 5 is already taken, so remaining numbers are 3, it is occurring for 1 time, 4 2 times, 5 we have taken, it is totally 2 times, 6 and 7 are for 1 time, right? Yes, 3 1 4 2 5 2 and 6 and 7 is 1 time. So here we have given the first place 5. So we can take one value, one number from 5. So that is, here you consider 1. Okay, 1 plus 1 plus 1, 3, 5, 6. So 6 factorial divided by 4 is occurring for 2 times. So 2 factorial. 5 we can remove. Remaining all are occurring for 1 time. So 3 1 time, 6 1 time, 7 1 time, 5 is also occurring for 1 time. So what is 6 factorial divided by 2 factorial value? It is 360 you will get. Okay, so this is the first case. Either it may happen. What is second case? So first value may be 6. Okay, so remaining 6 digits can be 3. It is occurring for 1 time, 4 occurring for 2 time, 5 is also occurring for 2 times, and 6 and 7 is 1 time. 6 already taken. So how many digits will be there? 1, 2, 3, 5 and 6. 6 factorial divided by 3 is occurring for 1 time, 1 factorial, and 4 is 2 times, 2 factorial, 5 is also 2 times, 2 factorial, 7, 1 factorial. So what is 6 factorial divided by 2 factorial? 2 factorial, it is 180. Okay, so this is second case. So what is third case? It may be 7, start with 7. So in that case also you will get 6 more digits should be occupied. Okay, so here you will get 6 factorial. 7 is also occurring only one time, right? So same like 6, so you will get the same value. It is 6 factorial divided by 2 factorial, 2 factorial, 1 factorial into 1 factorial, which is 180. So either this case may happen, 360 may come, either 360 ways will be there, 180 ways will be there, or 180 ways will be there. Any of these three cases, one of these three tasks can be done. So it means rule of sum. So 360 plus, not all need to be done. It is plus 180. It is the final answer. So 360 plus 180 plus 180 will become 720, right? So this is the final answer.